Oh, oh, oh! Happy holidays with New Bulb! Woo! Thanks for watching. So finishing off right now, we got 5.4 we're finishing, then 5.5. Whoa! Cruising, we're cruising. Okay, so let's see here. So now we're on number 17. Make sure you pause me. Try 16 on your own. Try 17 on your own. And then push play and see how you did. So number 17, we need to always factor first. Always factor the top, factor the bottom, factor the top, factor the bottom. Lots of factoring, always factor. So we can plot an x here. And so when we plot an x, we have on the top, we have x times x plus 2. On the bottom we have x. What's left? Well, x squared, take away an x, is just an x. Minus 2, the x is canceled, so minus 2. There we go. Okay, cool. So that is our reduced function, right? Reduced function. And so what's going to happen is that we're going to have something cancel on the top and the bottom, right? So we was going to have x equals 0 be a vertical asymptote, as well as x equals 2. So we was going to have a vertical asymptote. We was going to have a vertical asymptote at x equals 0 and x equals 2. But x equals 0 is actually a hole. X equals 0 is a hole and not a vertical asymptote because the x is canceled. And so that means that it's the hole, right? Yeah, the thing that canceled is called the hole. So the thing that canceled is called the hole. Now, how do you find the y value? It says ordered pairs. We'll come back to that in a second. But let's go and write down the reduced function there. So the reduced function is what's left after you cancel stuff in the top and bottom. And so that's going to be x plus 2 over x minus 2. Good. So the domain is going to be all real numbers. All real numbers. So all real numbers except what? So all real numbers except x can't equal 0 and 2. Right? So all real numbers except x can't equal 0 because that's the whole, and x can't equal 2. Why? Because 2 is a vertical asymptote and 0 is the whole. Nice. Okay, well, how do you find the y value of the whole then? Where is that whole located? Well, you take x equals 0, which is the x value of the whole, and you plug it back into the reduced function. Not the original, the reduced. So we take this guy over here like this, and we go y equals x plus 2, if it lets me. So y equals x plus 2 over x minus 2. And then we take our whole, which is x equals 0, and we plug it in there, and we plug it in there. So then we get 0 plus 2. That's supposed to be blue. So then we get 0 plus 2, right? Y equals 0 plus 2 all over 0 minus 2. And so those zeros go away, and you're left with 2 over negative 2, which is y equals negative 1. Woo! So that's what y equals. So that means we have an ordered pair now. We have an ordered pair. And so the vertical asymptote again is negative 2. But the whole is that an xy ordered pair, so it's going to be 0, negative 1. Is going to be our answer. Right? So 0 because of this guy, that's because of the whole, 0 because of this guy. And then when we plug it in to the original there and there, we get negative 1 for the y value. So 0, negative 1. Okay, what's our end behavior? Well, our end behavior is going to be, I don't see any squareds in there, right? I don't see any squareds in there. So then we're just thinking about the graph and what that looks like. So I'm thinking the end behavior like we talked about up here. So this means even, and this means odd because it's the first power. So I'm guessing it's going to be odd, and I'm guessing it's going to be in opposite directions. Opposite directions. Let's go ahead and double check right now. Let's go ahead and double check. So if we go to y equals, let me plug this function in. Let's see here. So we got, well, the original on the top is parenthesis, parenthesis. So x times x plus 2, good. So divided by, let's go and do x squared minus 2x. There we go. Okay, so that's going to be our graph there. Nice. So where did we say we had a hole at? Do you remember where we said we had a hole? Whoa, can you see it? Yeah, right there. Let's zoom in on. Can you see that hole? Yeah, you didn't think there was a hole, but look, there is. Do you see it? Do you see it? Yeah, do you see it? There's a hole right there. Right there. Right there. There's a hole. There's a hole in our graph, right? There's a hole. At 0, -1, right? This is -1. This is 0. This is -1. This is +1. There's a hole right there. There's a hole. Cool. I just had to point that out because that's amazing. Okay, so now let's think about our end behavior there. Nice, nice. Okay, so think about our end behavior. So again, looking at our graph, so our end behavior, let's zoom back out again. So our end behavior is going opposite directions, okay? Yeah, so our end behavior is going opposite directions, not up, up, or down, down. It's going, basically, I guess you could say it's going down then up, right? So end behavior is going down then up. Yeah, cool. So there's our end behavior. Nice. So then let's try it again. But pause me, try 18 on your own. Try 19 on your own. Pause me. So we're going to do lots of factoring here, lots of factoring. We got 5x and x. Ooh, we're trying to get 14. So 1 and 3. Pause me. Hey, stop copying me. You're supposed to try it on your own first, then check your answers. Pause me. So then we have a, let's see, positive 15, because that's the bigger number. Good. What do we got down here? What do we got down here? We got 2x and x. We got 1 and 3. Ooh, this is going to be tricky. So probably 1 and 3, that gives me 6x. And then we have a 5x, so positive 6x. And then minus 1x is 5x. We did it. Woo, we did it. Okay, so now, what's our reduced? Well, our reduced is just 5x minus 1 all over 2x minus 1, right? That's our reduced function there. It's our reduced function. Good. Okay, well, what canceled? Because that's the whole, remember? Whatever canceled is the whole. And so the thing that canceled is the x plus 3's. And so the x plus 3's is what's canceled, so we set it equal to 0, and minus 3 to the other side. So x equals -3. But now you got to go ahead and do this ordered pair, which means you need to plug it in to the reduced. You got to plug it into the reduced there. So that's going to be 5x minus 1 over 2x minus 1. And we're going to plug in a 3 for the whole with the x value to get the y value. A -3 actually. We're going to plug in a -3 there for the whole. Oh, that reminds me. I need to double check 17. Did we get the whole right? I think we did. Let's double check. Oh yeah, it was 0, so we're good. I was thinking of something else. We're good. Okay, beautiful. So we plug in a -3 here. We get 2 times -3 is -6 minus 1, so that's -7. Here we plug in a -3, and we get 5 times -3 is -15. Minus 1 is -16. Wow, wow. So that's positive. Negative divided by a negative is a positive. 16 sevenths. So our ordered pair is -3, 16 sevenths. That is a weird Ordered pair. That's a weird ordered pair, you guys, for number 19. Very crazy with our fraction there. But we'll take it. We'll take it. Okay, so our vertical asymptote. Remember how to find the vertical asymptotes? So you set the bottom equal to 0. So 2x minus 1 equals 0. We're going to add 1 to the other side. So we get 2x equals 1. And then we're going to divide by 2. Divide by 2. So we get x equals a half. So x equals a half is our vertical asymptote. The domain we're skipping over, remember? We're skipping over the vertical asymptote and the whole. X values. Domain is x values. So the domain is going to be all real numbers except x can't equal -3 and a half. So that's our answer, all real numbers except -3 and a half. Except -3 and a half. Don't forget the half. Don't forget the -3. Okay, good. So in behavior. So in behavior is a bunch of ones still. 1 over 1 over 1 over 1. Yeah, so there's no multiplicities. So I still think it's probably going to be down than up. But kind of hard to tell, right? Kind of hard to tell with this. Again, I would go to my calculator and I would go ahead and plug that in. And, or you can graph it by hand using an XY table, like next year, 1050. Do an XY table. So I'm going to try it without the whole this time, just to make it go faster. So 5x minus 1 divided by, just doing the reduce function there to double check my end behavior. I think it's down then up again, but we'll take a look. We'll take a look and see. Yep, looks like down then up again. Cool. Okay, beautiful end behavior there. Nice. So there's number 19. Okay, 21. So we didn't really maybe have time this year. We'll see if you did or not during the guided notes to do this. But I'm glad you're watching the video in case it's on the test. So we're just basically plugging in these percentages into the function, and that's really it. So we're just trying to plug it in, and find the cost of supplying the bins to 15% of the population. In a pilot project, a rural township is given recycling bins for separating and storing recyclable products. The cost C in dollars for supplying the bins to percentage P of the population is given by this function. So these are already percentages, so you don't have to turn it into decimals or percentages, they're already percentages. So find the cost of supplying 15%, supplying bins to 15% of the population. How much is it going to cost to get everybody these recycle bins? So we just take 15 and plug it in there, and we plug it in there, and that's it. Woo! So we got, in fact, it's going to do it 3 different times. So why don't I just use our calculator? Remember how to do that? You could use X for P. So say, well, let's do the first one by hand. First one by hand. So we're going to do 25,000, good, times P, which is 15, divided by 100 minus 15. And let's see what that is using our calculator. Okay, here we go. Stop it. Windows 11, you're evil. Stop it. Okay, so we go second quit. And we're going to do 25,000, 1, 2, 3, times 15. That's a huge number. 375,000. So 375,000. Divided by what? Divided by 100 minus 15. So 100 minus 15 should be 85. Good. So 375,000 divided by 85 is 4411.76. Here we go. So we get 15% is going to be 4411. Probably round up because you can't have 0.76 of a recycle bin, right? 0.76 of a recycle bin there. You can't really have that. And so we'll just round up to 4412 is our answer. So for 15%, we get 4412. Nice. Mr. Nubo, is there a faster way to do this? Oh, I'm glad you asked. There certainly is. So the next one is going to be 50%, 50. So why don't we go ahead, right? So why don't we go ahead and just store 50% there into x. And so now whenever I type in x, it's going to be 50. And now we just type in our equation. So parenthesis 25,000 times x, right? Times x, divided by 100 minus x. Where x is fit. Wait, don't forget parentheses. Careful there. So 100 minus x. And that's going to give it to us plugging in 50. So using our calculator, 50 is going to be when x equals 50 or when p equals 50, whatever. Y equals 25,000. 25,000 bins. That is a lot of bins, but that's definitely our answer. Okay, well, what about 90%? 90%, use our calculator. And so using our calculator, right, we're going to say that x is going to be 90 now. X is going to be stored in a 90. So when x equals 90, or p equals 90, either way there, we're going to say y equals, here we go. So here's the magic now, here's the magic. So we're going to go second, enter, and, oh no, I forgot to do the 90. So 90 store into x, good. And now when we go second enter, it's going to bring up the last thing that we did. And that's going to give us our answer. So 225,000. 225,000 bins. That's crazy sauce. Is that dollars or bins? Oh, C is cost in dollars, you guys. So that's going to be the cost in dollars. This one is also the cost in dollars. Right? This one's also the cost in dollars. That's so much money to get out recycle bins. That's crazy. No wonder our taxes just keep going up. Okay, last but not least, number 23. Try 22 on your own. You got this. Right? The hint is raise the $60 room rate, but 24% will be the new rates. Oh, you got this. Okay, Bill plans to paint the walls in his room. Before he buys the paint, he needs to work out the area of the surface to be painted. All walls are 8 foot high, and 2 walls are 20 foot wide. So all walls are 8 foot high, and 2 walls are 20 foot wide. 20 foot wide, 8 feet high. And the other 2 walls are 15 feet wide. Whoa. He also measured the combined area of his 2 doors and 1 window, or 90 square feet total as well. So don't forget the square feet, 90. What is the total area the bill will need to do the painting? So we're going to do timesing. So 8 times 2 is 160. And so there's going to be 2 walls for that. And so 2 walls there will be 320. Try it on your own. Pause me. You know how to do the rest. Pause me. So 8 times 15 is 120. And so 8 times, not working. My board is dead. Something's freezing. There we go. Okay, so 8 times 15 is 120. And so we're going to double that because we have 2 walls, right? We have 2 walls. Or not. We don't have 2 walls. What is going on? Okay, there it is. So times 2 walls. There we go. So that's going to be 240. Add them together. 320 and 240 plus, don't forget the 90. So that's going to be 560 plus the 90. It's not E. It's not E. It's not E. It's not E. Because you have to add the 90 in there. And so that's going to be another 15. Carry the 1. Yeah, 650. What the? That's not right at all. What did I do wrong? Before he buys the paint, he's going to area the wall surface to be painted. All walls are 8 foot high. 2 walls are 20 feet wide. The other 2 walls are 15. He also measured the combined area of those 2 doors and 1 window. Oh, do we have to take out? Paint the walls, but you have to take out the door? Oh, minus 90. Minus 90? Minus 90. Minus 90. And so when we minus 90, there we go. So we get 416 minus 9 is 70. Yeah, 470. We got it right. Woo! And so that's the reason why. Thanks for watching. Thanks for watching. See you next time. See you soon. Happy holidays.